Section 1.6, absolute value equations. So what does absolute value really represent? It's the distance from 0 on the number line. So if you think about the absolute value of x equaling 3, you're asking yourself, what numbers are 3 units from 0? So those two answers would be 3, because 3 is 3 units from 0, but also negative 3 is 3 units from 0. So when you're dealing with absolute value, you actually have 4 different possibilities. The first possibility is if the absolute value of u equaling k, where k represents a positive real number, that would be equivalent to u equaling positive k or u equaling negative k, like we just saw here in this example. The second possibility is if the absolute value of u equaled 0, which means what numbers are 0 units from 0? Well, that would be equivalent to u equaling 0. That's the only number that's 0 units from 0. What about property 3? What about option 3, absolute value of u equaling negative k? Can you have a number that's negative distance away from 0? No, so there's no solution. And the fourth possibility is if the absolute value of u equaled the absolute value of w, well, that would be equivalent to u equaling positive w or u equaling negative w. So it kind of goes back to that first possibility. So for example, solve the equations keeping in mind the properties listed above. 1a, the absolute value of x equals 5. That would fall under the first property, that x would equal positive 5 or x would equal negative 5. And those are your two answers. If you put them in a set form, it would be the set of 5, negative 5. That's another way to write it. 1b, the absolute value of x equaling 0. Well, that would fall under property 2 that said if the absolute value of x equals 0, the only answer would be x equaling 0. 1c, example, the absolute value of x equals negative 5. Well, that would fall under the third property, the absolute value of u equaling negative k. You can't have a distance being negative, so your answer would be no solution. And if you're using ALEKS, sometimes ALEKS likes to use the empty set. So, to solve absolute value equations, what should we do? The first thing is isolate. And this is something that I want to make sure you highlight or star, because you must isolate before you start with solving. So what does isolate mean? Get the variable by itself. Then at that point, you want to write two equations. The first equation, kind of like with property 1, is you drop off the absolute value and solve the equation. The second equation comes from dropping the absolute value, but placing a negative on the right-hand side. So again, dropping off the absolute value and placing a negative on the right-hand side. And then solve. Please always check your answers. This is something you should star. This is not optional. You must check your answers. The key takeaway for this is that you must write two equations. So the key takeaway for this section is you definitely want to write two equations most of the time, or make sure you just follow the properties listed above. So again, the key takeaway, make sure you're writing two equations. First things first, solve. Number 1, the absolute value of x plus 3 equals 12. The first rule of thumb is to isolate, so we need to subtract over the 3. And we get the absolute value of x equals 9. Then at that point, it will fall under property 1, so we're going to break that up into two equations. The first equation, we just drop off the absolute value, so x equals 9. The second equation, drop off the absolute value and equal it to a negative 9. Those equations are already solved for you, so therefore, they're your answers. Example 2. Absolute value of y minus 15 equals negative 10. First thing we should always do is isolate. So we're going to add over the 15. We get the absolute value of y equals positive 5. Then what we do? We need to break it up into our two equations. Again, that's our key takeaway. Make sure you write two equations. Dropping off the absolute value, we get y equaling a positive 5. Dropping off the absolute value and putting a negative on the right-hand side, we get y equaling negative 5. If you want to write your answers with a comma separating them, you're more than welcome to do so as well. So y could equal 5 comma negative 5. So now let's look at some problems that require a little bit more work to solve. For example, number 3, absolute value of 3x minus 4 equals 8. First things first, make sure it's isolated, and the absolute value is isolated. Second thing is we want to break it up into our two equations. First equation, we drop off the absolute value and equal it to a positive 8. Second equation, drop off the absolute value and equal it to a negative 8. So 3x minus 4 equals positive 8, or 3x minus 4 would equal negative 8. And then we'll solve each equation individually. We're going to add over the 4, so we end up with 3x equaling 12. And then we'll divide by 3 to get x by itself. So x would equal 4. On the second equation, we're going to add the 4 over to the other side as well. So we'll add the 4 over. So we'll have 3x equaling negative 12. We'll add over the 4. And we'll have negative 8 plus 4, which is negative 4. So 3x equals negative 4, and then we'll divide by 3 on both sides. So x equals negative 4/3. So we have two answers, x equaling 4 and x equaling negative 4/3. Now I did say we always should check our answers. So if we go back to the page before and we look at the absolute value of 9, plugging that into the very first example, we get the absolute value of 9 plus 3. Well, the absolute value of 9 is 9, and 9 plus 3 is 12. When you plug it in negative 9, the absolute value of negative 9 is positive 9, and 9 plus 3 is also 12. We can do the same thing for example 2. Those answers do work. And most of the time your answers will work. The one time that they don't work is if you have a no solution and you don't realize you have a no solution. And that's why I'm always telling students to check their answers. So I won't continue checking my answers, but I will point out an example where we have a no solution, so just be careful. On number 4, the first thing we want to do is isolate, so I'll start that one off for you. You're going to subtract 2 on both sides. So we get the absolute value of 2x minus 6 is going to equal 8. So on number 4, we started off with 2 plus the absolute value of 2x minus 6, close the absolute value, equaling 10. Make sure you isolate first by subtracting over the 2. Please finish this problem by pausing the video and make sure you get to those two answers. Example 5. 3 times the absolute value of 2x minus 1, close the absolute value, equals 21. Again, the first thing we should do is isolate. So how do we get this 3 over to the other side? We don't want to add the 3 because it's not 3 plus the absolute value. This was 3 times the absolute value. So we do need to divide by 3 to get the absolute value by itself. So the absolute value of 2x minus 1, close the absolute value, is going to equal 7. Now at that point, I will let you continue with the problem. Make sure you break it up into your two different equations and solve. So pause the video and see if you can get to the two answers of x equaling 4 or negative 3. Number 6, the absolute value of x plus 4 divided by 2 plus 5 equals 5. First things first, we want to isolate. So subtract over the 5. And when we do so, we get the absolute value of x plus 4 over 2, close the absolute value, equals 0. So this falls under a different property. And that one would looking back at our list, the absolute value of u equaling 0 is equivalent just to u equaling 0. You could break it up into two equations, and one would equal a positive 0, and the other would equal a negative 0. The 0 doesn't have a sign, so we don't have to do that. So we're just going to have x plus 4 divided by 2 equals 0, and then we'll need to solve that. How do we get rid of fractions? Multiplying by the LCD, so we'll multiply both sides by 2. Again, this is 2 over 1. So if you're multiplying by 2 but dividing by 2, they just cancel. So x plus 4 would equal 0 times 2, which is 0. And then we'll solve for x by subtracting the 4 over to the other side. So we'll have x equaling negative 4. And if you check your answer, it does check. So number 7, the absolute value of 4x minus 3, close the absolute value, minus 5 equals 12. I'll let you do this problem from start to finish. Don't forget to isolate. And lastly, number 8, the absolute value of x plus 1, close the absolute value, plus 6 equals 2. We need to start off by isolating. How do we isolate? Subtract over the 6. So the absolute value of x plus 1, close the absolute value, equals negative 4. Well, if you start trying to break it up into 2 separate equations, which is a takeaway for this section, it kind of looks a little bit weird because you're going to have an x plus 1 equaling a negative 4. And then if you drop the absolute value and put a negative on the right-hand side, 2 negatives make a positive, so we get a positive 4. And it looks like we're able to solve these. We can subtract over the 1, so x would equal negative 5. Or we could also subtract over the 1, and x would equal a positive 3. But if we check our answers, we're going to see that neither of these answers will work. For example, if I plug in a 3 into the original equation, the absolute value of 3 plus 1 is 4, and the absolute value of 4 is 4, but 4 plus 6 is not 2. If I check negative 5 plus 1 is negative 4, and the absolute value of negative 4 is positive 4, and 4 plus 6 is not 2. So neither of these answers work. Why is that? Well, once we isolated the absolute value and got absolute value of x plus 1 equaling negative 4, you could have stopped at this point because of one of the properties it stated. If the absolute value equaled a negative, you had no solution. So if you kind of forget that property, just make sure you check your answers and you would see that no answer worked, so you're back to no solution. Or once you isolate the absolute value, if it equals a negative, you'll know at that point that cannot happen, so you have no solution. And again, Alex likes to use the empty set.